Hello, good evening to my dear students. In today's lesson, we are going to discuss about valence bond theory, one of the very important topic in coordination compounds. So, in the inorganic chemistry, coordination compounds is very important for NEET aspect as well as JEE, and NCERT also coordination compound having huge weightage. Even in NCERT VBT, definitely they will ask a question as well as in NEET as well as in JEE. So first we are going to start valence bond theory. Valence bond theory. Valence bond theory. Valence bond theory. In valence bond theory, this also we call it as VBT. So in valence bond theory, we can come to know a compound having which type of hybridization and which type of shape, whether it is inner orbital complex or outer orbital complex, and whether it is paramagnetic or diamagnetic, we can come to know. So valence bond theory, first we are having in coordination number 4 complexes. Okay, in coordination number 4 complexes, first we will see coordination number 4 complexes. VBT we will see. In this one, first we are having nickel cyanide taken for -2. In this one we will see. So first thing what you have to do, you have to identify the oxidation state present on nickel. So nickel plus, there are 4 cyanide ions, each one having -1 charge. It is a monodentate negative ligand. So -1 charge present on the cyanide. So -1 and 4 cyanides are there. So 4 is equal to, we have to equalize the charge present on it. So nickel plus nickel -4 is equal to -2. You will get from this one, nickel is equal to, you will get +2 oxidation state you will get. So the nickel will be having +2 oxidation state here. So here next you have to write the electronic configuration of nickel. The neutral nickel having, nickel atom have 4s2 3d8 electronic configuration. So nickel to +2 oxidation state, you will get 4s0 and 3d8 electronic configuration. So this electronic configuration you have to write into orbitals. You have to write into orbitals. That time, so if you are writing d subshell first, it will be convenient for you to show the hybridization. The d subshell having 5 orbitals, we know it. So 3d having 5 orbitals, and the 8 electrons are there. So 1 2 3 4 5 6 7 8, and we are having in 4s 0 electrons, and 4p subshell also will be present. We are not writing. The reason is in that one no electron. So 4p 0. Correct? Fourth shell is started by 4s2 itself. 20 electrons itself 4s will start. Means fourth shell will start, in that there will be no electron. Okay. See, in atom is there like this, means it's the first shell, it's a second shell, it is a third shell, and it is fourth shell. Means nickel na, we are having electronic configuration 1s2 2s2 2p 6 3s2 3p6 4s0 will be 4s2 and 3d8. Nothing but 4p is there in that 0 electrons, 4d is there in that 0 electron, and 4f also is there in that 0 electrons. So since there is no electron in these orbitals, we are not writing it. Means that subshells are present. Okay, since no electron, we are not mentioning it. So this is. So after that, here these and all presented the nickel. So first we have seen the, we have to identify the oxidation state. We have to identify. Next we have to write the electronic configuration. Nickel +2 means we have to remove the electron from the valence shell. You can observe here, it is the third shell 3d8 and 4s2. So fourth shell is the valency. You can observe here, fourth shell is the valence shell. From that only we have to remove the electron. So you will get this one. So next the cyanide is what? It is a strong field ligand. Cyanide minus is what? It is a strong field ligand. Strong field ligand. Then what happens? The electron will get paired up. Okay, the electron will get a pair up. So electron gets paired up. So what happens here now? Low spin complex is going to form. Why? Why we are saying it's a low spin? Initially it was there unpaired electrons. The unpaired electrons becoming into paired. Initially spin was there. So now it is becoming, the spin is 0. Okay, plus half was there and plus half was there. It is becoming into what? 0. So that's why low spin complex we are saying. So now what will happen here? After getting paired up, we'll get 3d8 1 2 3 4 5. 3d8 na the 8 electrons will get into the 4 orbitals. And 4 is having 0 and 4p having 0. So now what happens? Which is the ligand here? Cyanide is the ligand. So we have studied in coordination compound, cyanide also called as, it is a Lewis base. So it will donate a lone pair into the empty orbitals. There are the 4 cyanides. The 4 cyanides are going to donate the lone pairs into the empty orbitals. That time what happened? Here one is d orbital is taken, one is s, another one is p, and another one also p. So you will get dsp2 hybridization. You will get dsp2, and it is called as the inner orbital complex. Why we are calling it as the inner orbital complex? The reason is the valency shell is the fourth shell, 4s and 4p. The valency shell is fourth shell. This number digit is there, no? The numerical number represents the shell number. So fourth shell is the valency shell here. So we are taking third shell orbital. Third shell d orbital we are taking. So that's why it is called the inner orbital. Okay, means even by having the valency shell is fourth shell, we are taking the third shell. That's why it is called the inner orbital. In inner orbital complex, we are going to use n-1d orbitals. We are going to use n-1d orbital. Means what? n-1d means what? It is what? Valency shell means it is what? Okay, penultimate shell we are using. N means what? Valency shell. Okay, penultimate shell we are using. That's why it is what? Inner orbital complex. Now we have to see whether it is paramagnetic and or diamagnetic. All are paired up electrons are there. So it is what? Diamagnetic. It is diamagnetic. So we have studied, okay, nickel cyanide taken 4. This complex we have studied. About this one we have to see the properties. From these properties itself they will give a question. So here what we can write? Nickel cyanide taken 4 minus 2 have which hybridization? dsp2 hybridization. So dsp2 hybridization means which geometry will be? It will be having square planar geometry. Square planar will be. Square planar means nickel, cyanide, and cyanide, and here also cyanide. So here the geometry will be the square planar geometry. Okay, it looks like a square planar geometry. And next it is a inner orbital complex or outer orbital complex. It's a inner orbital complex. Next, whether it is low spin or high spin, it is a low spin complex. Okay, and it is diamagnetic. It is a diamagnetic. It's a diamagnetic complex. Okay, the reason is no unpaired electrons. No unpaired electrons. Okay, from this one only they are asking question always. Okay, these factors only. They may give nickel cyanide taken nickel cyanide 4 -2. So which is, it is a diamagnetic or paramagnetic, or what is the hybridization involving, like that they will ask, right? And next we are having another complex is nickel Cl4 -2. This complex is there. In this one, first we have to calculate the oxidation state. So nickel plus the sum of the all oxide states should be equal to the charge present on the coordination sphere. Nickel plus 4 into each one chlorine carries -1 charge, that is equal to -2. So if you simplify this one, nickel you will get +2 oxidation state you will get. The second thing, you should write the electronic configuration. Nickel 4s2 and 3d8. Now nickel plus 2, what is the electronic configuration? 4s0 and 3d8. And these electronic configurations you have to write into orbitals. Now you are having in nickel first you have to draw the 3d subshell. 3d subshell carries 5 orbitals, you know, right? 3d subshell carries 5 orbitals. 3d8. So 1 2 3 4 5 6 7 8. Okay, always remember a d subshell having 5 orbitals, p subshell having 3 orbitals, s subshell having 1 orbital, and f subshell having 7 orbitals. And next 4s0. So the 4s you have to write later, then it will be easy to show the hybridization. Like you will be having always sp3. So if you write s this side, 4p this side, now you are unable to show hybridization exactly. Okay, for our convenience only we are writing like this. So here 4p is 0. So here we are having chlorine is weak field ligand. Chlorine is weak field ligand. So electrons do not get pair up. Electrons do not get paired up. So you will get high spin complex. You will get high spin complex. Why high spin complex we are getting? The electrons are not getting paired up in orbitals. Now next thing. So we are having ligands, chlorines. So chlorine is called as Lewis base. Okay, ligands also acts as what? Lewis bases. Which are Lewis acids then? Metal atoms are Lewis acids. Okay, central metal atom acts as Lewis acid. Now you can see you are getting sp3 hybridization. The s orbital from 4th shell and p orbital also from 4th shell. So what it is? It is outer orbital complex. And it is paramagnetic or diamagnetic? Paramagnetic with 2 unpaired electrons. It is what? Paramagnetic with 2 unpaired electrons. And since it is sp3 hybridization, it is having which geometry? Tetrahedral geometry will be. Always remember, if it is having dsp2 square planar in coordination number 4, dear students, always you have to remember that if it is having sp3 hybridization, then that is tetrahedral. If it is having dsp2, that is square planar. So we are going to write all the properties of nickel. Note, you have to remember all the properties of tetrachloronickelate 2 ion. Have which hybridization ma? sp3 hybridization. sp3 hybridization is there. And next having tetrahedral geometry. tetrahedral geometry. It is outer orbital complex. Outer orbital complex, and it is high spin. The spin is remain no. The high spin complex. It is a high spin complex. It is high spin complex. It is high spin complex and it is paramagnetic. It is paramagnetic. So n value will be 2. 2 unpaired electrons are there. So you will get the formula n into n plus 2 Bohr magneton. In this one, if you substitute n value is equal to 2 under root of 2 into 2 plus 2 Bohr magneton you will get. Means you will get, okay, you will get 4 to the 8 Bohr magneton. This one answer. So next we are having coordination number 6 complexes. Coordination number 6 complexes. Here first complex you are having tetraamino cobalt 3 ion. Tetraamino cobalt 3 ion is there. So first you have to identify the oxidation state. Okay, sum of this metal atom as well as the charges of ligands should be equal to the charge present on coordination sphere. Cobalt plus 6 ammonias are 0 is equal to plus 3. So cobalt you will get what? Plus 3 oxidation state you will get. So next electronic configuration we are going to see. Cobalt have 4s2 and 3d7 electronic configuration. We are writing cobalt plus 3 means plus 3 means you have to remove 3 electrons. So 2 electrons you are going to remove from 4s since it is valence shell, 4th shell. Next from 3d you have to remove 1 electron. So 4s0 and 3d6. So next we have to write these electrons you have to write into orbitals. D subshell have a 5 orbitals. So in that one there are 6 electrons are there. So 1, 2, 3, 4, 5, 6 electrons, and 4s having 0 and 4p having 0. Okay, the 4p is 0. Why we are writing 0? It since it is 4th shell is started, 4p subshell also available. Since there is no electron, we are not writing. Now ammonia in this case acts as strong field ligand. It is act as strong field ligand. Strong field ligand. So strong field ligand means what happens? Electrons get paired up. Electrons get paired up. Then what happens? It results low spin complex. The spin is going to reduce. A low spin complex. Then what will happen? This electron will get paired up here, and this electron will get paired up here. So the 6 electrons present in 3D are going to accumulate in the 3 orbitals like this: 1, 2, 3, 4, 5, 6. The 2 orbitals will be available for the hybridization. So 4 is 0, 4p 0. So ammonia is a ligand here. In coordination complexes, ligands going to act as a Lewis bases, and central metal atoms are acts as a Lewis acids. Okay, so here ammonia will donate a lone pair into the empty orbital, here also into empty orbital, and third ammonia, fourth one, fifth one, and sixth one. So which hybridization we are going to get, students? Here D2 sp2 hybridization we will get. D2 sp3 sorry D2 sp3 hybridization we get. D2 sp3 hybridization. So D2 sp3 hybridization, so it is inner orbital or outer orbital. The valence shell is the 4th shell, but we are taking the d orbitals from 3rd shell, so it is inner orbital complex. Inner orbital complex, and whether it is paramagnetic or diamagnetic, you can observe there are all are paired up electrons, so it is a diamagnetic complex. A diamagnetic complex. So first we are going to see here all the properties of hexa amino cobalt 3 have. Okay, what and all it is have ma? It have D2sp3 hybridization, D2sp3 hybridization, and it is octahedral geometry. It have octahedral geometry, and it is inner orbital complex. It have inner orbital complex, and it is diamagnetic, and it is a low spin complex. This one. Okay, and sometimes they may ask very important point that if it is having D2sp3 hybridization, which d orbitals are involved? Means always remember dx square y square and dz square orbitals are involved. Okay, plus and one s orbital, and one is px, and one is py, and one is pz. This one you have studied in 11th standard hybridization. The same thing will happen here also. Okay, right. Next, another complex we are having hexafluoro cobaltate 3. Why we are telling cobaltate 8? We are saying since the coordination sphere having negative charge, we have to say the metal atom we have to end with 8. Okay, hexafluoro cobaltate 3 or hexafluorido cobaltate 3. So here first we have to see the oxidation state. Cobalt plus 6 fluorines, each one is -1 charge, is equal to -3. Then you will get cobalt is equal to +3. So the cobalt electronic configuration is 4s2 and 3d7. So cobalt +3 oxidation state we have to write. Electronic configuration, cobalt +3 oxidation state electronic. Cobalt electronic configuration we have to write in +3 oxidation state. So +3 means removal of electrons. First you have to remove from the valence shell. So 4s we have to remove 2 electrons and 1 electron from 3d. So we will get 4s0 will get and 3d6 will get. So that 3d6. So 1, 2, 3, 4, 5, 6 and 4s having 0 and 4p having 0. This one. So here fluorine is a weak field ligand. A weak field ligand. So electrons do not get paired up. Electrons do not get paired up. Electrons do not get paired up. Okay, so it will remains as a high spin complex. High spin complex. Now each fluorine is a ligand. So sorry, I forgot to draw here. D subshell having 5 orbitals, 4d 0. So each fluorine will donate a lone pair into orbitals. Why it is donating lone pairs? Since it is a Lewis base. Ligands are going to act as a Lewis bases, and central metal atom acts as a Lewis acids. Why Lewis acid? It is accepting a lone pair into metal atom. So that's why it is a Lewis acid. So we will get which hybridization? sp3 and d2. Why? It is one s orbital and 3 are p orbitals and 2 d orbitals. So sp3 d2 hybridization. So this is having octahedral geometry. Octahedral, and it is outer orbital complex. Outer orbital complex. Why we are saying outer orbital complex? All orbitals, outside orbitals only utilized, and it is paramagnetic. Paramagnetic with how many unpaired electrons? There are 4 unpaired electrons are there. Okay, so now we are going to summarize the total complex, that hexafluoro cobaltate 3 have what and all? First thing, sp3d2 hybridization, and it has octahedral geometry. Okay, and it is high spin complex, and it is outer orbital complex. Why it is outer orbital complex, ma? The orbitals have involved what? 4s, 4p and 4d. That's why outer orbital. Why it is high spin complex? All the spin was remained unpaired only, so it is a high spin complex. And next it is paramagnetic. With 4 unpaired electrons. 4 unpaired electrons. So what will get formula? Under root of n into n plus 2 Bohr magneton. Okay, so there are 4 unpaired electrons, then 4 into 4 plus 2 Bohr magneton, then 24, 6 4 the 24 Bohr magneton. So you will get around 4.7, you will get answer. Okay, 4.7 to 4.8. This is VBT, one of the very important concepts. From this one they may give any complex, they may ask whether it is high spin complex or low spin complex, or outer orbital complex, or hybridization they may ask, and low spin and paramagnetic or diamagnetic also they may ask. And it is a very important concept in coordination compounds. I hope you have understood this concept, valence bond theory, VBT. If you like this video, you can subscribe my channel, and you can like the video, and you can share the video with your friends. Thank you, my dear students.